Hi everyone, how are you doing? Okay, I hope you're doing okay. We're gonna get started, so if you can check out your notes and your assignments in Canvas. So today we are going to use Jupyter, or at least I can show you how to do that. Let me get to Canvas here. And so this week we are going to work on Cython, which is going to be using C compiler, and we can use it as a package to write our program and make it faster. So we are going to work on the assignment for this week. There are 13 questions. Let me zoom in and then I'll share screen. My Word application is a little slow today. Let me see if I can open it from. Just 1 second. Oh. Okay. So you can find the notes in the assignment in Canvas. I had added those today, and then I'll add the lab. So the lab, mainly we are going to work on just additional programming. And then I'll also include the quiz review for everyone. Yeah, my Word application just failed. Let's restart it. Okay, so in the notes, you can find that there on Cython. And if you read the chapter, you will likely find some information and example. Let me see. I'm getting an error for Word. Okay, so here are notes. We're going to touch on what Cython is. And so hopefully by the end of the session, you know a little bit more about Cython and how you can use it. So this is an extension for the Python programming language. We can use C base definitions for functions, variables, arrays, and classes. Very, very close to C, but it is a mix between C and Python. We can, because C is going to give us more efficiency, and it's going to use compiler to be able to build our program. So it is an easy way to construct the interfaces that will be external to C and C++ routines. You can include, or you can use the syntax for Cython, and with Cython, you would find that if we use with Jupyter, we would use IPython. So Cython, you will need a compiler, and on Windows environment, you will need to install Visual Studio Community in order to use the compiler that comes with that, or you have to run setup tools every single time. So in the source code, that when you write the source code, you have to save it as a .pyx, which is a little different than what we've been doing with regular Python file. And when it compile, what it's going to do is it's going to create the applications when it builds that through the compiler. Okay. Now, it is an optimizing static compiler, for Python programming language and Cython programming language. So it is the bridge between C and Python. It makes it easy for you to use other C packages. And as you know, most of the tools that we're using for Python is built out of C. There are a lot of different libraries, especially when you're working with IoT devices, that you will find that those extensions are written in C. So it is a good way for us to use it as a language to wrap external C libraries. And that way you can embed a certain functionality in your applications. And you can refer to the documentation, and there are resources and tutorial, as you can see here. There are basic tutorial on how to use, we're going to touch on static typing, and then how to work with NumPy and arrays and additional information with C++, as you can see there. Okay, so I provided a link for you to look at. I recommend that you take a look at the library and find out more how to use it. So as I mentioned that it uses compiler, we have to install various tools in order to use this particular package. Cython, for Windows environment, it's best that you would use Microsoft Visual Studio. Community is free. And then you would need to install the builder tool sets or the builder essential tool sets. Now on Linux, you would need the GCC, which is usually equipped with almost all Linux releases. On Ubuntu or Debian, all you have to do is you need to do sudo apt-get install build essential, and it's going to pull the packages that you need in order to have the compiler. Now for Mac OS, if you're using Mac OS, you need to install Apple's Xcode, and you would refer to their instructions. This says that you can use install DVDs, but we don't do that anymore. You can go to Apple website, and on the develop section, you will be able to find Xcode. And Xcode is used for a lot of different things, including C# programming. So you can download Apple Xcode. As I mentioned, Windows environment, you have to use Visual Studio. And then I also provided a link later on for you how it walks you through how to install various tool sets in Visual Studio. So the option that we have for, since I'm using Windows environment, I can either use Visual Studio, or you can also use Jupyter Notebook, which is, it uses your browser application and your native file system to build. So we would first start with doing pip install. So you would go to your command line in any OS, and I would do a pip install Cython. And what this will do is it's gonna pull the packages that you need if you haven't installed it, and it's gonna put it into the location with Python 3. Now, if you're using Apple system and Mac and Linux, make sure that you use pip3, or if depending on the Linux version, you have to do sudo apt install, and then you would pull the Cython packages there. So in the first question, let me zoom in real quick. It asks you about what Cython is. And we can say that Cython is an optimizing static compiler. And you will find this on the first couple pages of your notes for Python programming language and extended Python programming, CPython programming language that's based on Pyrex. And it allows us to write C extensions for Python. And Cython is ideal for wrapping external C libraries, embedding Cython into existing applications, for creating FAST modules that will help with performance for execution. It uses the .pyx extension, which needs to be compiled to produce a C file using Cython command. So when you build the program, your source code will be saved as a .pyx. You'll have to write a setup file, and with that, you have to run the setup file with your source code. It needs a compiler in order to build. And to execute the file, you would use the Cython command. So recommendation in documentation, textbook, and all the resources online that you would use an IDE like Visual Studio, right? Or a web-based environment like Jupyter in order to run this. If you have Windows, if you have other OSs, the recommendation is listed in the documentation and also your notes. For question 2, as you saw, I had shown you how you can install Cython. You can use pip command, and if you're using Python 3, make sure it's pip3. So we would do pip3 install Cython, and we need to make sure that we have a C compiler to run Cython script or code. Okay. Any question? So before we use any packages, just like all the other chapters, we talked about installing it first, making sure that it's linked to your language directory. And so if you have Python 3 installed and it's not setting up with the system path, likely that you will run into issues. So we want to make sure that we have that established, and we've done that in the last few weeks. And we'll talk about how to do Visual Studio shortly. Now, as I mentioned, that we have to write setup tools. So in the textbook, it provides an example, and I also include that in the notes, but I'll open the file shortly so you can see. So the setup tools is it's a utility tool that we need to manually produce a .c file. So basically you're converting a Python file into a C file. And as it does that, it's going to need, and then when it executes your program, it needs to compile it to be able to give you the output. So when you build your code, after you write your source code, you got to write a setup tool setup.py. You can name it anything you want, but however you name it, you are going to use this particular file with your source code, which is a .pyx. Then when you run a Cython command line utility, that's going to create a .c file from the .pyx. So it's going to convert this. And what it's going to do is going to take this and make a .c file. Then it's going to use that .c file to compile. And what that will do is it's going to share the object library so you can import from Python. You can use Jupyter Notebook or Sage Notebook, and a lot of universities are using this. So it's just a good way for us to kind of be introduced to Jupyter. It's free. And on Jupyter, you would find that you use IPython in the back. So all the magic commands that we've been talking about, In the prior chapters, you will see that. So the commands are slightly different using magic command. And that is going to allow you to do code inline. So it will have input field and you will be able to write your code within almost like a shell. This is an easier way for you to be introduced to Cython, as if you don't want to set up all the other extra step in order to build. But if you're familiar with C++ with Visual Studio, all you have to do is add in the packages. And you can run things in Visual Studio as a developer through the developer command line. Okay. So with that, I wanted to show you something. So here is a file, right? Let's say this is our source code. And in this source code, what we're doing is we are going to define a function that's going to say hello to, and we're passing the variable name. This is in Python. We're going to print, and we're going to print hello and the name. And this is the example that's provided in the book. Then when we write this, we are going to save it as a .pyx. So you simply go save as, and you would say hello.pyx. Okay. Then you are going to create another file called setup.py. And in this, we are going to pull from the setup tools library. So we have to import in the setup tools because it needs to use this file to make a .c from our .pyx, right? It's going to take the .pyx source code and it's going to create another file with the .c extension from it. Then we are also going to pull in Cythonize from cython.build. Okay. And you might see various format in how you can write setup tools, but in this particular case, inside the setup, we just want to specify what our variable would be, right? What kind of value is that going to hold? So we want to have a string and it would say hello world app. And then the extension modules that's going to come from this Cythonize, which is to build this .c. And we are going to pass the name of our source code file. And then after that, we would wrap up the setup tool. So you would save it together, okay? And when you use command line, right, you would first make sure that you have Cython, and then you would do a Cython and then call this file. And actually you have to run the setup tools and then it's going to execute the hello. That's if you already have a C compiler. Okay, so that's if we don't use an IDE or Jupyter. So what I want to do next is I want to walk you through the process of how to use Jupyter. And here it talks about the steps that we just touched on. Okay. And then how to go about running the setup tools. Okay, you write it, then you're going to run Cython command. Okay, and then if you use Jupyter or Sage, you would have to install, and then you want to call up the application, and then you would load it. Okay. So the step is that we would then go to command line, and we would say pip 3 install Jupyter Notebook. Make sure I have my syntax correct there. Yep. So it would show me that my requirement is already satisfied, but as you go through and install this, right, you would see that it would go through and it will pull the Jupyter Lab packages, so it would install it. So through the browser application, you can run Jupyter or Sage. Okay. Now, some institutions, they already have a server that's available. All you have to do is they already set it up. You just have to log into it, and then you'll be able to write your code there. I know UCR uses something similar. I think they use a Google product, but it's pretty much the same format using IPython. All right. So once you have it installed, then you are just going to call up the application, and then inside it, you're going to load the extension. Okay. Now, this is another example of Hello World, right? Like what we saw, I just captured the code and I put it there for you so you can see how that's done. And when you build this, if you already have your C compiler, then you would just use command line and you would do a Python. You can do Python 3 setup.py, setup extension in place. And then it's going to start the session and it's going to run the say hello. Now, if you want to know the specific on how to use Jupyter Notebook, you can click this link and it's going to take you to how to start using Jupyter Notebook. When you do this on your own system, what happens is it's going to create like a directory, a working directory from your file system. Now, if you're using a server, then you have to log in. And then you simply would start with selecting Python 3, which is going to be the notebook that you want to use. And Jupyter is created for Python. You can use it with R. And once you set up the type of notebook you want to use, then you're going to load the extension in the first input. And then after that, you are going to use your magic commands and then write your code. Okay. And within it, it's going to build it for you. It's like running REPL online or running an online compiler, very similar to that. Okay. Then after you do that, you just click run, and if it works every time, then it's going to output. Now, my experience with Jupyter, when you're using it to your local machines, what's going to happen is sometimes it does time out, so you have to end it and then reopen it, because if you let it idle for a while, it doesn't remember your extension. So this is a way that you import in Cython in Jupyter by using the magic command for that extension. Okay. So the link provides you some example on how to use it, and even talks about creating static attributes, which we'll touch on. Okay. And then for the basic Jupyter Notebook, you can go here, Cython documentation. They also link that using with Jupyter. which is here. Okay. Now, the cool thing about this is that it walked you through step by step, and then you can click Cython and it will tell you the code in Cython and how that is compared to Python. Okay, so you can see the difference. Now, you know that when you run regular Python, it is slower than when you run Cython because the interpreter, right, is not going to execute as fast, or it's not able to maximize the parallel execution when you have multi-core. So the way that we would make a better application is to use Cython and be able to capitalize on, you know, your modern processor where it has multi-logical core to be able to execute the task in our application. Okay, so there's additional tutorial and things on how to build Cython code through the documentation. All right. Then I also found a link for you for those of you who are partial to Visual Studio. And if you took CIS 5 or 17A or C, right, most of all the professors require that you use Visual Studio. On this particular page, you will find on how to do the installation. We'll talk about different OS, okay, and then using Windows. So you need to install upgrade tools, okay. Now, after you install this, I'm just going to copy this and run this so you can see. It's going to pull down the setup tools, which is the package that you need for the compiler to be able to convert your source code. Then, sorry, I lost my page there. Then you are going to install Visual Studio, but make sure that you read this section carefully. It tells you that you are going to download and install, but you need to select C++ build tools. So when it goes through and it asks you for the workload in the installation, you are going to click on the C++ build tool. But if you did this when you took CIS 5, right, likely that you would have the build tool already there. And then you are also going to select Windows 10 SDK. Okay. And so that way you make sure that you have those two packages. And it will look something like this. So you would select these and then you click install. And then after that, you are going to open up developer command prompt, and then you would do pip install Cython inside Visual Studio. So it's going to bring in Cython and link it to your IDE. Okay. Now, another option is that you would do Cython, no Cython compile, but if you want it compile, you want to run this. Okay. And then here, it walks you through how to do the compilation, but I wanted to show you how that's done in Jupyter. And then also in Ubuntu, it talks about that. So check out the information. This is written by one of the developer that supports this particular package. So it gives you the details on how to do it in different systems. Okay, so let's work on the next one. I tried to write down as much details as possible for you to run Jupyter. So now to install Jupyter Notebook, we already saw how to do that with the pip3 install Jupyter. And then you can issue Jupyter Notebook. So after I install, I simply call it. I call the executable through my command line. And it takes a second. It's going to open up my default browser and it's going to tell me where, it's going to ask me where I want my directory to be. So I can go into the location of my folder where I keep the program. And what it will do is going to create these IPyNB, which is the IPython notebook for various code or source code that I'm going to write. And you can create as many or you can remove, right? As you can see there, and you can also import in your source code that you've written outside of Jupyter by opening the file. So if I wanted to open this, I can actually select it to open. So once I have my Jupyter notebook open, I'm going to go ahead and click new here. And I'm going to select Python 3. What it's going to do is it's going to create a new notebook for Python 3. And you want to pay attention to this at the top because it's browser oriented. You know, if you lose connections, it will say no connection. That means that likely when you run your code, it's going to fail. And then if it's not trusted, right, it's going to get blocked because it's a way that we can integrate into an application. And if Windows doesn't trust it, it's not going to execute it. Okay, so you want to make sure that it's trusted here, and you can also modify there. Anytime that you need to open and save, you can always go to File. So once in a while, you can save your notebook. So it saves the status of that particular program that you've written in Jupyter. And then you can also open, make a copy. Anytime you run into kernel issues, you can go here and you can restart your kernel. So that way it would reset and then it's gonna, and we can run it again. You can also shut it down. So it's using your kernel in order to execute this. And then the cells are simply these field right here. So you can run a certain cells, you can select a certain cells, move across, up and down, and then you can look at your output. Then you can insert a cell. So if I need a field in between where I want to execute something else, you can also insert it there. So it acts like a regular notebook in that we can add in the field and we can change it. We can look at certain things. And then your widget, you can save it as a certain state. You can clear it, you can download it, and so on. Okay. So make sure that we start with the type of notebook that we want, see how it saves it at various times. So in our assignment, after you open up your Jupyter, you select new and you're going to select Python 3 in the drop-down menu. And then you need to load in the extension, and but keep in mind that you already need to install Cython first. Okay, so the first line of my Jupyter notebook is going to be, we're going to do a magic there and then load, right, extension. And then you want to say Cython or the package that you need.
Professor?
Yes.
How did you open up Jupyter Notebooks in your browser? Because I'm having trouble opening it up through the command line.
So if you, okay, so did you install it already?
Yes.
Okay, then you just, you would use Jupyter Notebook. I would probably put down Jupyter, but put in Jupyter space notebook.
Mm-hmm.
And it should default to whichever browser that you're using. It could be Edge or another browser. I just happen to have Chrome as a default. So
Okay, let me try one more time.
is that working out for you?
Nope.
Okay. Possibly that you might have something blocking also, maybe like sometime application filter, like your security application, that might also block it as well.
Just type it in the command, right?
Yeah. You want to share screen so I can
Yeah.
see? Okay. Scroll up. Did you install Jupyter already? Okay, so successfully install. Yeah, that's fine. Okay, so you have. Okay, up more. Keep going up. Yeah, so okay, successfully install send trash back home packages. Okay, go up more, let me see. Okay, so it says consider adding the directory path prefer suppress Python software foundation. Yeah, it's having issues with the path again. Go up, I think, yeah. So see how your Jupyter kernel.exe, it says the script in Jupyter kernel.exe and Jupyter run.exe are installed, but not on the path. Okay, so that means that it's there, it's just not on your directory path. Let's see, let's take a look at your, okay, so it says Python 3.9. Yeah, you see how it didn't put it into your Python 3.9. If you look at the path in the middle with all the warning that it's telling you, it doesn't put it into your, yeah, it's because that it's either linking to your OneDrive or it's default saving it to your OneDrive. It's for some reason.
Okay, and I know that I have Anaconda on here, so I'm not sure if it's going in there.
It shouldn't have
Okay.
to be. So 1 second. You can probably set your path. I just want to make sure.
Okay.
Yeah, so what you can do is you can go to see user, your username, app data, local packages, and see if it's actually, it says Python Software Foundation. So let's try that. Open up your file manager. And then go to this PC. And then you can go to C drive. Go to users folder. And then go to your name there, the third folder. Okay, and then it says to go to, yeah, see how there's a .Jupyter extension there? Open that up. Yeah, so I think we have to link that. Right click your path. Just right click it. And then copy address. Okay, now open up your control panel. Then go to system security. And then go to quick system. And then, wait, go back. I'm sorry. On system, allow remote. Is there an advanced options? Right click your system. Yeah, it's not letting me. Okay. System maintenance. Yeah, go ahead and open that up. It should be a way that you can do system path. Click to open that. Notifications. Okay, on the right side, there's advanced system settings. Go all the way to the right.
Oh,
Yeah, you see in blue, it says advanced. Yeah, right where your mouse is at. Down.
right here.
Yeah. And then go to environment variables. And then see how there's path. You need to click on that path. On your system variable path, the lower one, the second one, lower.
Oh,
Yeah. Click on path.
oh, here is, okay.
Yeah. And then click edit. Okay, so this is where all your executable path lives. Okay, so you're gonna go ahead and click new. And then right click and paste in your link. Yeah, and then click OK.
Okay.
Okay, and then click OK. Okay. So now let's try it again and see if it's not, we have to edit that link because I have a feeling that I'm missing the packages there.
Okay.
Arrow up. Yeah, just no, go down, go back down, and then just press your arrow key on your keyboard up.
Oh,
Yeah, press enter. Yeah, it's not, see, it's not running the .bat file. Okay. Stop share for 1 second.
okay.
Let me find the actual packages. I think you have to modify that path real quick. Okay, just give me a
Okay.
second. And then for those of you who already worked ahead, you can continue with the steps. Let's see to go. Let me close my notebook and then let me reopen. Yeah, I think because just like before, how your system is installed from, it's defaulted to OneDrive, it's doing that. So you have to make sure that you set up the, so let me see, pip 3 install Jupyter. Okay. All right. So go to your file manager and then you are going to, here, let me paste it in here so you can see. 1 second, let me share screen. Okay, so oops, let's redo that. So you are going to go to C drive, users folder, and then your name instead of your, that will be your username. And then you're gonna go to app data. And then it's gonna be under local programs. Yeah, so follow this path,
Mhm.
and then these are all where your packages live, okay? Because it will tell you that in the installation here that's where it puts it. So Jupyter is living in this path, and all the widgets live in that path. So what you have to do is you have to navigate, you have to copy that path and then go in and edit the system path that I showed you earlier,
Mhm.
and then make sure that you paste this path in there and see if it's going to execute. Okay.
Okay, so it's gonna be users name and then app data.
Data, and then local, and then programs, and then Python 3.39, and then it's going to go into live, and then go down to site packages. Okay. And here you will find, I have a lot of different packages that I
Mhm.
install for other things, but your Jupyter core lives here.
Mhm.
So that's the path that you need to set up. So I would copy this, okay, and then go to control panel, and then go to system security, back to system,
Mhm.
and then, sorry, mine's slightly, let's see. Yeah, and then you just need to go to your advanced system and then paste that in the second path, the system environment variable, not the other one. Okay.
Okay.
Yeah, because the first one is going to be the user, and see if it's going to execute that way.
Okay.
That's how you set your path.
Can you just copy over and send the path just so I can see that's an example?
Yeah. 1 second. Let me see if I can go back. And then here. And then here. And then go to advanced. And do environment variables. You got to go to path, edit, and then you just need to put in new, and then V here,
Mm-hmm.
and then click OK.
Okay, so
Yeah,
should try that one.
yeah. So let me put in the chat so you can
Okay.
see what my path looks like.
Okay. Okay. All right. I'll go ahead and try to do that.
Okay.
Okay.
Yeah, you wanted the second path, not the first one, because this is the variable for the user.
Mm-hmm.
And I do have my stuff linked to OneDrive too, but
Mm-hmm.
not always, right? So you want the
Yeah.
application to execute from the system
Mm-hmm.
path there. And as you can see, I have SQL Server, PuTTY, other things that I
Mm-hmm.
use. So you can add in the path whenever that you need to
Okay.
use. Okay.
Okay. All right. I'll go ahead and try
Okay.
this way. Thank you.
You're welcome. Let me know how it works out.
Okay.
All right. So for the rest of everybody, sorry, let's pick up. We are going to go into back to our, let me reopen my, just to clear. Jupyter Notebook. Okay, so this opens up. Then what you can do is you can go into your folder that you wanted to use, a new notebook. Then you are going to open up, you're going to load the extension Cython. And here is where you just hit Control and Enter, or you can just click Run. Okay. If you do it again, it will say it already loaded, right? Anytime that you want to reuse it, you can do a reload, okay? Now, in the lab or in the assignment, it tells you that the next line you're going to do is going to be your magic command Cython. So what this does is it's equivalent to your import Cython in Jupyter or Sage. And then after that, we are going to call on the Python command. So anytime if you use time it command, you would do, the magic command would time it. So here you are going to do a Cython. So anytime that you code for Cython, you want for it to remember that you are using the Cython command, right? And then, so after that, what you're going to do is you are going to put in your code like this, okay? So you would have a definition of your function called hello, and then we want to just simply print from that. So we would say def, right? Hello. And now keep in mind that this is I'm sorry, I should do C def. Keep in mind that this is Cython. So what you have to do is you have to, this one, the way that they wrote it is just a definition of the function in Python, but later on you would do a CDEF. Okay, so let me go back and change that back. And then we are going to do a function, and then we are going to print, right, hello world, like this. Okay. And then what we'll do next is we are going to run it. Okay, nothing, if you don't get any error, that's good. And then we just call the function and then run it. And there you go. Okay, now if it's throwing some kind of weird error, it's because it's either timing out, you have to like reconnect to it or reopen it. And then if you wanted to stop it, you can just interrupt the kernel so you can stop that there. But anytime that you write your code, then you would do a run there. Okay, so here we know that our function works, right? Because it outputs it right here. All right, so after we call hello, we see the output. Now what we are going to do is we are going to use the proper Cython syntax. Okay, platform error, unable to. So I recommend, Michelle, do an install for your utility. So that means that it might be missing the utility for a compiler. Let me go back here. I recommend you do this. Where is it? Run this in your command line, but do a pip3. I know that this is supposed to be for this, but it's still using this in the background. So yeah, either that or reinstall Jupyter, because I think that the batch file it didn't pull the Visual Studio or the setup tools batch file, and it gives you that error. Okay. So here we are, right? And then if you want to save this, you just go File, Save As, and then you can just say like assignment EX1 or what was it, 4, right? Whatever you wanted to name that there. So what it's going to do is going to save your status. All right, so we got our hello world. Then we are going to do the next one. In this one, we are going to do a running sum. Now in Python, you will declare a variable by doing cdef, and it has to be typed. Okay. Yeah, let me know if reinstalling Jupyter helps. And then put in your environment path. Is the Jupyter app core supposed to be in the inside path that you provided? Yeah, if you look inside packages, they have to be in here. If they're not in here, right, here's the app core. Oh, you mean to link it? Yeah, you can include it, but I think it's only gonna use because it's gonna use other like widgets and other things. So I only put in the side packages there. It should be able to find it there.
So it's just I'm not seeing the package. I'm just gonna put in the Jupyter Core 2 like that. It's just I'm not seeing it when I open the site package.
Yeah, so something happens when you did the install, it didn't put it in there, right? So
Yeah.
so what you should do is you should try to maybe upgrade your pip. If you do the command in yellow and then you can just reinstall the if you don't see if you don't see all the files for Jupyter, that means that it didn't get installed properly. Maybe something failed there. Okay.
Okay.
Yeah. So when you go here, you should see all of these.
Okay. So if I were to do it all over again, I should upgrade
pip.
And
yeah. And it will tell you like you can do a Python -m and then you would do an upgrade pip version in the when you run pip, it's going to tell you it's outdated. This is how you upgrade it. And then you would do a pip install Jupyter. I'm sorry, pip3 install Jupyter, and you should be able to pull it. Because if you have other Python version, if you don't put pip3, it will just put it for version 2 or, you know, the prior version. So yeah, it should live in your lib. And then if you go down to, you should find site packages. And it should have all the packages for, these are all the libraries, right? Or the files, the directory for the library. So you should see Jupyter there.
I just see Py input, I think. That's all I see. And
yeah, is it not able to run?
yeah, it's just the site packages doesn't have the Jupyter.
Yeah, so that means that Jupyter didn't install there for some reason. It should, if you look at the error, sometimes it would say, because when you run Jupyter, it would say something like this, right? Because it's gonna make sure that you have the token, and it's gonna run it from eventually a .python file.
Okay, so I'll just try to upgrade.
Yeah, I'll help you at the end if
Okay,
we have some time.
Okay, all right. Thank you.
Yeah, no problem. Okay, so I got this, and then on the next one, I'll open one for you actually. And then if you want to do a new notebook, you can just do a new notebook, right? And then we can just stop this one, and then we can go into here. Sorry, let me redo that. Python 3. Maybe it saves me time if I just open. 1 second. Getting so a little delayed. Let's save this. Let's close out of that one. And you do see that sometimes it does do this, right? And then sometimes you have it working and then you're writing and sometimes it's doing, it's not, you have to reopen it and then, you know, that's the downside of using browser oriented things. Okay, so let's, while I wait for that, I wanted to show you this. So in your Jupyter, when you declare a function, I mean, a variable, you always start with your Python magic or Cython magic command. So you would do the percentage symbol twice, Cython, right, in that cell. And then you would do a CDEF. So what this does is it's gonna tell the system that you're declaring a variable, right, or a function for that particular program. So here we would do a CDEF and then you need to type it because it's C oriented. So all the data needs to be typed. So if you're using integers, you would do int and then your variable name. After that, you can also assign the value to the particular variable. Now, this is, the issue is because we're using 3.0 and it's not going to type it as, it's trying to type it as an integer, as a whole number, and you're trying to use a decimal here. So it's not going to like it, and it's going to tell you that you should use double instead of int. Okay. So when you're using values, you just got to make sure that it's the appropriate type for that particular value. Same as C, right? So if we're using whole number, we do integer, int. If we want to use float, we can use float, we can use double, and so on. And for something like using a for loop to add and return from a function, so you can create a regular function that what you see with Python, right? We say def example, and then inside it, we would declare the variables, right? And we would do a declaration for the static type using Cython by doing cdef, int, and then the variable name. You can also initialize that there. In this case, we use a 0. And then for the for loop, we would do a for range, and then we would make it run 100 times, and we will increment every time, and we will return. So it's going to give us the result as the output when we call on that function. So when you write your function, you simply just define your function inside it. You would declare your static type variable, and then be able to use your function by in the next cell running it. Okay, so that's what the next step in your assignment would be. For the H, you would first have your magic command Cython. Then you would define a variable called A, and you initialize it as 0. You have a for loop that you would loop 10 times, and we will increment it. And then we would print A, right? And so now using the regular Cython magic command is a little bit different than annotate. And annotate is going to give you more details as far as the option, and later in the chapter it talks about that. Let me see how my thing is. Let's restart this. Okay, so I'm going to go ahead and click open. And let's do unit 5. Okay, so okay, so here you can see that it shows me not trusted, and then I wanted to give it trust. And here is my code. Okay, so for step 5, I would have this, and when I output it, and you can save it afterwards, it will save exactly what you have as far as the notebook. When I output it, I would have 45. Okay, and then when I do the annotate and I run it again, what it does for me is that it's going to show me each line, right, on the Python interaction. So when you click this, it's good, you're going to be able to see the C code that Python generate for it. So you would be able to see Python and C together when you use -- annotate. Okay. So if you want to see more details, you would be able to expand it. So what this will do is, it tells me here that it's using the Cython magic, and at this location, it initialized a 0 for me, right? It assigned a 0 at that memory location. Then for the next line, when I run the for loop in the back, this is what's happening. Okay. And you can always move it back by clicking the plus sign. And then for number 4, we saw that. Okay. So it's like stepping through the program itself, but you're able to see the C side of the house by using Cython. Okay. So when I print A, this is what it's doing in the back. It's going to go pull, right, the A value, and then it's going to be able to plug that in. And so that way it would output. Okay. Now, see how this, sometimes you get something like this because it's timeout. So it's not able to see like my import or my magic command. And it does do that once in a while, right? So what you will have to do is you will have to reconnect back to it, or you will have to restart it, or you will have to reload this at the top. Okay, so I would then have to add in a cell, and I would do %symbol reload extension Cython, and then be able to run it. Okay, so either way, whichever product you use, you're going to have a few steps in the preparation of building the application. If you're running it like this, it's a good way to test it, and you can also download the file. But if you use Visual Studio, you still have to make sure that you link it, and then you write the file, you click build, and then it's going to be able to execute it. So either way, there are like a few steps in prior to it if you're using Windows or any other OS. Okay. Questions? Okay, so once you see the annotate, how that's different than the regular Cython magic command, right? You can answer the questions. Now, what we're going to do next after this is we're going to cast it. So we are going to take this value, which is in decimal or floating points, and we can cast it into integer. Okay. And as you know, for C, you can cast it by just specifying the type. So let me open. Let's go back here. I'm sorry, let me stop it. Let me see if it pulls up. Oh, that's my number 6. Sorry. Okay, I mislabeled that. Okay, so here I have I reload it because and then you can do reload Cython, and then I would do the magic command. I would define my variable. You can name your variable anything you want. So the type that I'm using is float. And I would give it an assignment 3.147, and I wanted to print it. Then I wanted to define another variable called C type where I'm going to cast it, initialize it at 0. And then I'm going to go ahead and cast it into integer. I'm going to cast the varpy, which is the original variable 3.147 that it holds, into integer. So it's going to drop off the decimal point. It's only going to keep the 3 when I cast it. So make it into a whole number, and then I wanted to print it. Okay, and let's hope that it's going to load. Of course not. Let me see. Restart it. Let me rerun it. Oh, the frustration with Jupyter. I don't like it, but you get the idea. So I tested this earlier, and everything should work, right? So here you should have a variable, and then when you cast it, you simply just put in the type that you're casting it to, right? What you're converting it to. So I would cast it into integer, but if I wanted to cast it into double, I can do a double here, right? Usually we would do a float to a double, where double is going to give us, a larger container size, and then I would just simply print it out. But, direct cast, you can cast it to integer, you can put it into double. So the assignment simply allow you to learn how to define the variable and then how to cast it. So in Cython, when you define, you need to do a CDEF, the type of the variable and the variable name. You don't have to assign it there, right? Let's say that if you want to assign it below, you can do it that way. And there's no semicolon in this because you're still using Python on top of C. So you would define the function and its the variable and its type, assign a value, print it, and then you don't have to initialize that there. You can just also again declare another variable in Cython, and then you can assign it a value, which is it's going to cast it into integer from the previous variable, and then print. Yep. So let me try running that and then run this and see. Yeah, so here what it's doing is telling me that it's not seeing what that is because it's ignoring this right now, my Cython. That's the buggy thing about this. Question? Let me see if I can reissue the command. Run that and then run this. And yeah, it's still doing that. Sorry, I have a bunch of them. Do we have any projects involving Jupyter? Probably you don't have to use Jupyter. We are going to do a lab, but I'm going to use Linux. I want to show you different interface so that way for Jupyter server, it's much better than this instead of the local ones because it's using your kernel and your local system, so it's boo-boo. But but if you're using like a server for Jupyter, it's really good. You can also use the online version of it, you know, but it's still gonna capitalize on your local machine. So no major projects relating Jupyter. Our lab, you can use Linux, you can use Visual Studio. You don't have to run Jupyter. Like I said, right, there are instructions for you to use other products, but I want to show you how that's done. So in my case, I'm gonna have to close this, relaunch it again, and so that way it's gonna be connected because once you have it saved and reopen it, it's gonna lose the command information because remember that everything goes to cache, and if it's already been updated with other things, it's not gonna remember what you imported or what command you're using. Okay. But you can definitely write a source code with the setup tool and then be able to run it that way. Okay. All right. So you see how that's done. Okay. Here's my code. Okay, so that was for 5. Then we are going to use static type for Cython, and we are going to define the function next. Okay. So I want to walk you through how to use the syntax for Cython. So here you go find some example. We already saw how we can define it as a regular Python function, and then we can add in its body. We saw that with hello world. Now, when you define it as a Python function, when you run the time it, you're going to see that it's going to be slower than when you define it as a Cython function, as a static type. So it's because the interpreter is used when you're using a Python function or method. Okay, but if you define it as a Cython function, right, it's going to compile it and you're going to see that it's going to be faster. As their example shows that when they run it with the same amount of loops, when you do the examples that Python function compared to the Python, you see that it's a little faster. Okay, like 0.5 nano, or actually, no, quite a bit faster. Okay, so because it's C oriented, you're able to use struct, enum, and type def, and class. All the things that you can do in C as a data structure, you would still be accomplished in Cython. Okay, so the CAS information that we just, or the CAS exercise, you can also refer to page 5 for the example. Function is next. So when we define the Python function, we would just do def and then we give it a name and then we would specify the argument for our variables that we're going to use. Now, in the case of C, this is you have to say what type it is, right? Whether it's integer or you know, double or float, the data type. Okay. So here what we have is we have 2 types of functions. The first one is the traditional Python way, is where we would use just the Now another way that we would use this for using Cython is we would use cpdef. is we are going to specify, declare our, or define our function using Cython. And as you know, C uses data type in the function, so you have to specify the type of data that you're using and then give your function a name. Inside, for your argument, your variables needs to also be typed. Okay, so you can use it with CPDEF or CDEF, right? It would be the same. Okay, so here you can see that this is the same as this. Now here it talks about how it basically achieved the same thing. And in this case, we're just defining a function, right? For our max inline, and we would return A if A else B. So you can do a CPDEF and then your function with the type, or you can do CDEF and then the function and the type. Okay, and so for the next question, you can refer to page 6 of your notes for the example. Now, it says that the function body is small. It is convenient to add the inline keyword in front of the function definition. The function call will be replaced with the function body itself. So when you call it, it's using this keyword as a placeholder to be able to pull the body of the function there. Okay. I did write it in Jupyter, but I think I put it also in, let me pull it up for you. Okay, so for number 6, we're going to write a function that calculates the volume of the cube, given the width is 4.5 inches. And we want to provide the screen capture. If you can't do it in Jupyter, you can just write the code right below it. I'm fine with that. Okay, I just want you to know how to use the syntax. Okay, so let me open it. Let me close some of this stuff here. I have a lot of things open. Okay. So here is my number 6. Again, if I'm using Jupyter, I gotta load the Cython or reload, right? And then on this next one, I want to use the magic command. So I would do %symbol Cython. Then I wanted to define my function, my variable. So my width is going to be 4.5. I should make this a double. Sorry, wrong type there. So if I'm looking at the example that's shown in the notes, right? I need to include the type of my function and then the variable that I wanted to use. Oh, where is it? So here we would do a double cube volume, right? And then we wanted to pass double width and double qual. So then in the calculation, we just simply take the width and we wanted to cube it. So we can do a PAL or you can do the multiplication or operator, the asterisk symbol, however you wanted to do that. And then I wanted to return the volume and I wanted to print it. Okay. So the only thing that we are doing differently than your regular Python is we are going to do a cpdef and then we are going to type it. Okay. And then for our variable, we're also going to define it with the the cdef and then the type. Yeah, it's going to hang there because it lost my Python command or Cython command. Now, if you're using Visual Studio, you can take this code, right? You would save it as a .pyx, and then you can build it from there. Any question? Okay. For 7, it asks you to do the static type that contain members to access the attributes. So we have to create a class. And as you saw that I put it all on one file. Here's my class. Okay. So just like the other one, we are going to define the class. Okay. And then we can do we can use public, oops, I'm missing an L there. And then your width, your height, and so on. So here's my class definition. I have 2 member variables, width and height. And as for the class structure, I can instantiate, right, those members by using init. And then I would have the self, that's a placeholder. And then I would do a width and then height. Or I can use W and H because here I defined what W and H is. And since I'm using self, you just have to do self.width, self.height, which came from here and here. And then I would have another function called describe. I bring down the self and then I print. So you want to load the extension before you have used the command. Okay. Any question? Okay, so I only have one class in this one, right? I have 2 member variables. I instantiated those, and then I have another member function to be able to print those out. Okay. And that's what the assignment called for. And you don't have to make it exactly like this. You can write however you think that would be fitting, because there are other ways that you can create a class. Question. Okay, so the notes for classes, if you're referring to the notes, all you have to do is do a CDEF class, right? Like what you've seen here. You wanted by practice, we wanted to use the capital letter for our class name. We have member variables, so you have to indent. And then you can instantiate like what we've done here. And since you're using self, you just do self dot and then the object, X and Y. Okay. And then again, you can add in you can use a function to be able to use the extension from that class. So you can access that class that way. Any question? Okay, so we see how we can declare, right, a class and its members and be able to use it to print for number 7. Okay, so for 7, that's what we need to create. And then 8, it asks you, how do you display, sorry for the typo, an address of a C variable using printf. And printf is a built-in function that's in C. This is equivalent to cout in C++ and equivalent to print in Python. Okay, for C, it's a little different that uses printf. So in order to display an address, we need to use reference variable in C or C++. And the way we reference a variable is to use the ampersand symbol. And so if you're using Jupyter, you would start with your magic command, right? But if you're not using Jupyter, you would write your script and then you would use Cython command to run your script. Okay, then I would define my variable. I'm following the example. I would say CDEF AA. And I need to bring in the printf function from the libc studio library. And this is equivalent to your include IO, right? Stream, include IO stream in C++. That's where it actually lives, is printf. So this is the library that you need to bring in to be able to print. And for Cython, you would use a C import statement. So you would say from libs, wherever the library is, you would import that method or that function, printf. And then after that, we can execute the function printf, and we simply reference the variable that we previously declared. What that will do is going to print out the address of the memory where it creates the variable A, or whatever you call your variable. Okay. So in order for printf to work, you got to make sure that you import in the library that it's using. And to print the address, the memory address, we would just use the ampersand in our variable name. And the application behind this is you wanted to see where your data actually is stored, right? And when you work with array, you're gonna see that it's gonna create that space, and inside it, it's gonna cut the section that it would need for the elements inside that memory location. Compare that to a variable. The variable, it's gonna create that one space at that memory address, but it's not creating any kind of contiguous space within that memory location. Let me do something real quick. I'm going to copy this. Let me put it on here. Any question with 8? We just have like a few more to go and then we'll finish. Okay, so you saw how that's done. We can use this to print out the memory location, and it will give you a long, right, output where it shows your memory address. Then let's look at pointers and things. Okay, so here it talks a little bit about class, and then it goes into sharing declaration. So sometimes you might have different modules that you would use, right? And you would declare classes and its members, and then you would bring in the classes. So it talks about how you need to make sure that any kind of C-type declaration and your C declaration you can use C functions. But ultimately, when you bring in the module, when you're using Cython, you have to do C import, not import. You saw that in the last code that I showed you. Okay. And the inheritance, because you creating that class structure, you would still have the same inheritance rule for the object-oriented environment. Even though C is not object-oriented, but you're still gonna have inheritance as it will still work with C++. So here we go. Okay. You would do a C import module, or you can write from module import name and then ask whatever that you need. So the example that we see here is that we have, right, we're using a enumerator here. So you would declare an enumerator, and then you declare a struct. And from those, this is dishes.pxd. So you need to save it as a pxd. And then you would import that into a pyx by using C import statement. And I took this from their documentation so you can see how that's used, but you know, there are other examples available online for this particular case. So we declare things here. We're going to use it in our source code for Cython. And then we would be able to access the attributes from dishes, which is another module in our source code. So similar to what you've seen with modular environment for Python. It's just the way that we use the file extension is a little different because it's running on top, C under and Python on the top. Okay. And also in this one, you see that it's using the reference D here. Okay, so the highlights for this is here. It says if the txt file changes the module C import from it may be to be recompiled, the Cython build Cythonized utility can take care of this. So when you're using this, what happened when it builds is it's going to be able to look into that file, right? And it's going to cache it just like how you've seen it in module in Python, and be able to create objects and be able to reference that when it's building, it's compiling. So that kind of show you a little bit. So there are some example here that you can create different modules using mathlib library, and then you would import in a specific function and then use that function inside your custom function. Like min, max, cereal, and so on. Just remember that we're using C import. And you can create array in Cython. So when we're using a pointer, all that does for us is when we create a variable that's going to point to the location where the value is stored, we can then refer to that pointer variable every time we need to access that value. It's kind of like, you have a saved location on your map called A. And every time that you need to go to that location, you just need to go to A to look up the actual address and the direction to get there, right? So the system, what it does is it creates a container which stores the memory address where the value is stored. It's a way that it references the value through that memory address. And that's what pointer does. Okay, so here what we see is that we can create a variable called A, like what you've seen in our assignment. And this variable is going to hold the address, the memory address, right? It's going to reference that location. Then we can create another variable called A pointer. And that A pointer is going to point to the location where the value exists for A using the asterisk. So everything that is used like a pointer in C, it will work in Cython. Okay, let's practice. Number 9, we are going to write the Cython code that uses pointer to display a value of a variable in IPython or Jupyter. So again, you are going to use Cython command. We are going to define a variable called var1 in my case. You can name your variable anything you want, like A in the previous one. And I'm going to declare another variable called pvar1, which stands for pointer var1. And what I'll do is I'm going to use this to point to the value that was initialize for var1. Okay, it's going to map the location where that value is located for my variable. So once I created the pointer and I'm using the asterisk here, right? And then I would initialize my variable var1, and then I print the pointer for var1. And as you know, for those of you who are familiar with C++, when you reference a variable, you got to dereference a variable. When you're using a pointer, you always use it with a reference, right? Same thing with Java. So in the example, also in the book, is also a good thing to follow if you're not familiar with pointer. But if you're familiar with pointer in C++, the same rule. Okay. And then if I wanted to do printf, I'm going to make sure that I have the import for it. And you notice that here it's going to tell you, oh, I'm missing that. Your pointer is going to be the reference of A. So let me add that. I forgot to reference it. So p bar 1 is going to be, there you go. And then I didn't have the lib C studio. CM. Type print. That's the complete. Okay. So here we declare a pointer variable, and I need to put the asterisk there, sorry. My pointers variable is going to reference, right, the location of var1. And when I store the 100 into var1, it's going to be able to pull, right, when it prints there. And that's how you use pointer. Any question? Okay, got 10 minutes. So let's get through the next one. So you can create an array just like how you would create an array previously when we were doing NumPy, right? You can use NumPy with Cython, not a problem. But in C, you can to specify the number of elements inside your square brace. That would be the length of your array. So in number 10, it asks you to write the code to print the location of the array. So again, we're using Cython magic command. We are going to define an array that store integer. It has 6 elements. And when we print, we need to import in the printf, and then we simply print array. So what this will do is it's going to print the memory address of the array. If we want to access the content of the array, we have to send it through a for loop, like what we've done, right? So as far as accessing the content of the array, unlike Python, Python does there's some container we have to put it through the for loop, but if you issue the print array or print list, it's going to access the content. It's going to show you the container with everything in it. But for C++, when you do a print array, it just tells you the location where it creates that container. And since we didn't initialize anything, it'll just tell you the location. Okay. And then if we want to access the content that we initialize as the values, then we have to put it through a for loop. Okay. So once it creates that location, then it's going to use the contiguous space, right, to create the element location inside that array, starting with index 0. Question? Okay. So for array information, you can go further down, right? It shows you here on how you can create an array. You can also make two-dimensional array, multi-dimensional array, like this. You can use NumPy to generate randomized values in your array. That's what we'll do for the lab. Okay, and here it shows you, right? This is a good example to see. Now, page 13, it shows you that you can print the location of the array or the index, the first index, right? Reference that location for the first index. It's in the same array, so it's going to give you the same memory address for the first one and the second one. The index is at that location, so it's going to give you the memory address. That's the same as the array. Okay, and the only difference is that we're using a reference here for the index. So it has what's called memory views. And what that is just it's able to go to the memory location and view the content. And there's some example using NumPy. All right. Last thing. Okay, so we'll do some practice with this for our lab since we did NumPy last week, and then we're going to do some array and some container. And also, I want to also point out that if you have your Jupyter, you can use time it command in Jupyter and be able to run your bench test. Also build your C profile through Jupyter. All right, let's answer the next question. I know I'm getting close to the end. Describe the purpose of typed memory views in Cython. This is just a way that we can simplify data access in any container, whether it's an array, a struct, whatever. It is an object that is able to reference a location in the memory. It doesn't own the memory, but it can read the change in the content, or it can just read whatever that's there in the content. Okay, so that's what we call a memory view. So you can use the type memory view to be able to access the content of the container or what's been updated to the content. It doesn't own that location, but you're able to view it. Read only. Okay. Any question? So using Cython, you can also slice. But in the view, since it's only view, you cannot slice. Okay. You can use numpy and then slice your array and access a certain index of your array. So in that case, you would then need to import in numpy. So for 12, it tells you to create a code that would contain 2 arrays, and we can randomly generate the values. So what I did was I created the exact same shape for 2 arrays, and then I would slice it, okay, and copy it. And in the book, it provides a similar example. So you would first need to import numpy, and then you would define your array. So what we're doing is we're going to take one dimension of the array A, and we're going to copy it to the array B. So here, what you're doing is you're going to take the dimension, the first dimension of array A, and cut it or slice it. Then we are going to create the array B, randomize it. Then we are going to copy it. Take the second dimension and then copy it to B. So ultimately, we would have same data from A to B by just updating using the equal operator. Okay, so that's how you're able to cut an array, copy it, put it into the another dimension of your second array. Now we don't have to randomize it. You learn, you can zeros those, you can put values in them. As you would see the output, you would then have whatever that was in array A, it's going to put it into the second part, the second dimension of your array B. Okay, as we're using 1: here. Okay. Any question? Does it still need Cython on the top? Only if you're running Jupyter. But if you're using Visual Studio, you would write this in and then run Cython command at the end. Okay, so if you're using Jupyter, yes, you're correct. You need to have, you gotta load Cython and then you gotta use the magic command. That is correct. Either way, you still have to use the command. Okay, I got a minute or two, so I will show you where you can find that information, right? So after it talks about memory view, it goes into how you can use that, okay, to access the content. So you're able to use that to print, copy. And so a good example for our last exercise that we just looked at is this one. It's on page 16. And there are prior example as well if you have the book. I took some snip of it so you can see. And in this one, they zero it out so you can see the difference, but I just randomized them. Okay. Then it talks about annotation view with profile, right? So if you can use the A option, if you're using the HTML file, but this is the command that you would do. So if you don't use Jupyter, when you're using Linux or another OS, you would say Cython-A and then your file. Okay. And then and then you have to tell what browser you're using and then the HTML file from the .pyx file. So what it has to do, because it's through the browser, it's going to have to make this into an HTML after you use that option, and then you're going to use that to view your annotated step through Cython code. I don't know if that makes sense. It should, right? Okay. And it looks like this. We did this at the beginning. So if we don't use Jupyter, that's how you do it. Okay. With the -A option. Okay, last question. We can use this to check. Now, every time that your compiler is at work, it uses system directives, or what it's known as compiler directives. And the way that we can add directives to help it is to use decorator with the @ symbol, or we can include comment at the beginning of the file. We can also use command line options, and you can see more directives here, but these are some of the things that we can do to add the directives for the compiler. So what that will do is it's going to be able to do the bounds check. It would look like this. So you would have C import Cython, and then you would add the decorator there. You would say Cython bounds check false. That if we wanted to block the bounds check, and then you would have your function. Okay. So the whole point in this is to show you that decorator can be used to access the system, or I'm sorry, the compiler directives inside your code. Now, if you don't do this in the code, then you have to use a command, which is Cython, and then you have to specify how you want the bounds check. If you want to include it, you would say it is true. If you don't want, you want to block it, you would say it's false. Okay. And we can disable the bounds check or enable it by putting in the bool. Okay. And then it shows you how you can also create a script and then run it for the benchmark that builds a profile using C profile. So in the last question, how do you add compiler directives in Cython code? You can use decorator or a context manager inside your code. You can also include comment at the beginning of the file. And if you already wrote your code and you don't have the decorator or the comment, you can use Cython command with the options. That's what it shows you with the bounds check, right, in the book. And that's how you can access directives. Okay. Okay, so don't worry if your Jupyter is not functioning like it's needed. I'm fine with you writing the code inside your document, right? But if you want to test it, right, if you're using Windows, you can use Visual Studio, follow the instructions on the page that's provided. Make sure you install everything that you need and then test it. But if you wanted to use Jupyter, if it times out like what you see me doing here, like my kernel just times out there, right, you want to reload it, right, just open up command and then run the Jupyter again. It usually works when you code it and then run it right then and there. It doesn't do well when you save it and rerun it. Okay, so I just want to let you know. So if you run the code right then and there, it should execute it if everything is correct. Okay, any question?
Professor, I'm still having trouble trying to run Jupyter